Okay, so if we look at set 3, this is page 467, this is 11.6. What they're doing is they're trying to help you to develop the conversion formulas for Fahrenheit and Celsius here. And so they're giving you this line here, and like here you get the point 032, and if you think about it, isn't 0 degrees Celsius equal 30 degrees Fahrenheit, right? So they're giving you, in the points, they're giving you the Celsius temperature, and in for the X value, the Y value is the Fahrenheit one. Now, given some more points. Well, actually, they just say, in general, Celsius is the first number, Fahrenheit's the second, and then we know that 100 degrees Celsius is boiling and 212 degrees Fahrenheit is boiling, and I'm not fitting that on there very well. So that's kind of our given information. So what is the slope of line AB? We'll go through all of this, okay? It would be subtract your y's on top and subtract your x's on bottom. And what I'm going to do is pick the number so that we can actually get a number slope. So if we had 100 and 212, that's point, the point up here they call B. Let me show you a cool way to find the slope and not have to stretch it out so much. Isn't point A 032? Doesn't my slope formula, this is kind of an informal way to look at slope, but if I stack my points like this, aren't I supposed to subtract y's on top? If I come over here and I'm subtracting my y's, aren't these my y's? Okay, so what's 212 minus 32? Is it 180, I think? Okay, so it's 180 on top. Look, I can just subtract the points stacked like that, and I don't have to worry about, I don't know, sometimes it makes it easier. I don't know, if you don't like it, you don't have to do it. But 100 minus 0 is just 100. That's the x's. The thing about it is you just got to make sure you get the stuff in the right spot. You can't put the x's on top, even though they come first when you do this. So if you follow the formula and do the y's first and write it down and then go, oh, I need to subtract my x's and do it, you get this. Let's reduce it. The zeros would cancel off, right? And 18 and 10, 2 goes into 18 9 times, and 2 goes into 10 5 times, right? So my slope of this line is 9/5. You remember your Celsius and Fahrenheit conversion formulas? One of them has 9/5 and the other one has 5/9 in it. This is how we're getting it here, okay? So this is actually kind of working with those conversion formulas. I know the 7th graders, for instance, do this a lot. They're always reviewing it. They're always reviewing these formulas, but we're actually getting to see where they come from now. So that was number 1 on set 3. Problem 2 says write an expression for the slope of the line AB in terms of the coordinates A and P. So they want me to use this information right here. So the slope would be, I'm going to put the P first just because I know what I'm working toward here. I know these are the conversion formulas, and if I kind of want them to turn out to look like the conversion formulas, it might be easier if I just said, okay, if I subtract my y's, couldn't I just say F minus 32 on top? Because that's what we do, we subtract our y's on top. And on the bottom, if I subtract my x's, that would be C minus 0. What is C minus 0? C. So the slope is equal to F minus 32 over C. So now I have a number for the slope and I have an expression for the slope. They're the slope of the same line, aren't they? Right?
Yeah.
So aren't they equal to each other? Right? I got a number and I got an expression that has the variables in it. So what do you think I'm going to do if they represent the slope of the same line and they're equal to each other? Well, how can I make an equation out of that?
Just put 9/5 equals F minus 32 over C.
Yep, right. Okay, so that's probably what they're going to do, and that's what they do. If you look at number 3, they're kind of stair-stepping you through this. That's what they ask you to do. They say take your results from answers 1 and 2. So what was it, 9/5? Since I can't, yeah, 9/5, and then we had F minus 32, and C minus 0 was just C, so we'll just write C. So that's on 3, that's what they're wanting you to do, just set them equal, and then 4 and 5 is just let's solve them for the different variable.
You just cross multiply.
Yeah, we can cross multiply, but in 4, they want me to solve for C. That means they want C equal something, blah, 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 blah. And they want the F and everything else on the other side. So we're going to cross multiply, but I'm going to get C by itself. And then in the next one, they're wanting me to get F by itself. So we're going to do the same thing on 4 and 5. We're just going to get the different variable solved by itself. And these are the conversion formulas. So if you cross multiply, you get what? 9C. And then over here, we're going to get 5 times F minus 32. And they want C by itself, so I'm going to circle C. What do I do to get C by itself? Divide by 9. Now I'm going to write it a particular way. I could draw the fraction bar across the whole thing. You know, I could have put that fraction bar from 5 all the way through F minus 32, or I can just write it like this. Does that look familiar to you?
Yeah.
That's the conversion formula from, and this is how you normally, like you could draw the fraction bar all the way across, but when you normally see that conversion formula written, this is how they write it.
So they don't want you to cross them to distribute it that far.
No, we're going to try to leave it looking like the formulas that we would see in our science books. That's what we're doing, is really getting those formulas. And now for number 5, we're going to do the same thing all over again, but this time we're going to get F by itself. It's a little bit more work. So for number 5, let me write that same thing that I've got on number 3 down. Here's one I... Why didn't I think to do this bigger line before now? I don't know. All right, so we want to get, this time they want F, they say solve for F in terms of C, which means get F by itself. C is going to be on the other side. So I circle it. I hope that doesn't confuse you, but let me just put this in parentheses since there's more than one term there. If I cross multiply 9C, and on the other side, 5 times, I'm going to put my equal here, 5 times that whole thing, F minus 32. But they want me to get F by itself. F is caught up inside of here, and I want to get down to it. PEMDAS backwards is what I need to think here. That's not going to show up well. If I go PEMDAS backwards to get F by itself, first I need to add or subtract anything. I can't really add or subtract anything here yet because that's in parentheses. So what I probably should do is distribute, right?
Okay. You would divide by
I actually could do that. I could, you know what, that would be the easier thing to do. I could say, because there's parentheses here, there's nothing I can add or subtract first. So I could divide by 5. That'll be the faster way to get to it. Let's just do that. Y'all can see this easy enough, I think. So 9/5 C is equal to F minus 32. They wanted F by itself. It's not yet. What would I do to get it now? Add 32. That parentheses kind of messes. So it would be F, and it's going to look backwards because I've got the F on the right side. F equal 9/5 C plus 32. That's the conversion formula if I know the Celsius and I want to get the Fahrenheit. You know, normally you see it written like this, and you can rewrite it this way if you want to. Okay. All right. So number 6 says, is there a temperature for which? How could we think about this? Do we have an expression for F? Was it 5/9? Tell me the expression for F that we got. F equal what?
9 plus 32. Yeah.
And what was in here?
It's 9/5 C.
Okay,
Plus
thanks. I just can't, I don't remember. And then what was C?
5/9 F minus 32.
Isn't there like a parentheses here?
Yes.
Okay. Okay. Is there a place where they're equal?
Do you
Let me think of it. So I look at this and I'm going, what should I do here? I could do this. I don't want two variables here because that's too confusing, right? So let me do this. F is equal to, this was an expression for F here, but aren't these two things equal? Like, if F is equal to C, we don't know if that's true or not yet, do we? So I could say, well, I only want one variable here, so let me put F here. I don't know if this is going to be true or not. I'm going to put a question mark over it just to emphasize that I'm not sure yet. So if it's true, then if I leave F on here and then write C, we know F is equal to C, but C is this over here. I could put 5/9 F minus 32. Let's see if we can make this work out. We might end up with no solution. We might end up with something that looks like 2 equals 0, and then we know there's no solution. But we may end up with a number. So let's see what happens. All I've done is substitute this in for C, because I'm going to say, is there an F equal to C? So let's see. If I try to solve this, I would get 5/9 F minus 5/9 times 32. Somebody's got my calculator, but I think if y'all want to multiply that out real quick, and you can go ahead and give it to me as a decimal, is fine.
17.7.
You know what? Let me go ahead. Let's see. That would be what, 160 over 9. Let's just leave it as a fraction. So because it'll be easier to solve it if we do. Now that I think about it, so I think it would be 160 over 9. So if I want to solve for F, let me get all my F's together. Let me subtract these F over here from the F that's on this side. So if I subtract 5/9 F from both sides, I'd have 1 F minus 5/9 F's would be 4/9 F, right? We write the F down and we subtract the numbers out front. And this would be negative 160 over 9 that's left on this side. How would I solve for F now? How do I get rid of 4/9? On a fraction, I could divide both sides by 4/9, but wouldn't it be easier to multiply by the reciprocal? So we'll multiply both sides by 9/4. Those would cancel out. And then over on this side, look, we could cancel the 9's out. 4 goes into 4 one time.
Please release all students leaving at 2:30. Please release all
And 4 goes
students
into
leaving at
160 40 times. I would have F equal negative 40. And that would be my answer. At negative 40 degrees Fahrenheit and negative 40 degrees Celsius, the temperatures would be equal. I think, unless I've messed up.